Alright, so in this video we go over section 1.3, the complex number system. In this section we are going to go over a review of complex numbers and their operations such as adding, subtracting, multiplying, and dividing them. At the end of this section we're going to solve some quadratic equations that give rise to complex numbers as their solutions. Alright, so where is the imaginary unit coming from? Okay, let's consider these two equations, these two simple quadratic equations. Alright, so in this case, well, if we solve for the quadratic term, we get x squared equals 1, and then we apply the square root property. Take the square root to both sides, don't forget the plus minus, not enough space over here, and we get x equals plus or minus the square root of 1, which is plus or minus 1. Alright, so those are the solutions, x equals -1 and x equals 1. Alright, now let's look at the second case. So x squared equals -1. Alright, just from here, without solving anything, let's think about what quantity squared equals -1. As I mentioned a few times on the previous section, when you square a number, whether this is a positive number or a negative number, the answer is meant to be a positive number. There is no way you can just square a number and get a negative number. That is, well, in a way impossible, if you will. However, alright, in order to give a solution to this equation, well, let's take the square root on both sides, plus or minus. Well, so the solution will be x equals plus or minus the square root of -1. Well, again, you might remember from intermediate algebra that we cannot take the square root of a negative number. So in order to explain this, well, so since there is no number, apparently there is no number whose square is a negative number, we introduce an imaginary number, right? That's called the imaginary unit. And so that's why this will be plus or minus the letter I. Okay, let me write this again. X equals -I and x equals I. Alright, now from here I would like to define something else that will be very useful. So that means that I squared equals -1. We will use this when evaluating later on multiplications and divisions of complex numbers. Alright, so how do we define complex numbers? So complex numbers are typically denoted with a z, in which we have a real part, which is a, and the imaginary part, which is b. B is the imaginary part, which is the number that multiplies the letter I. Okay, so now let's take roots of negative numbers. How do we do that? Well, so taking the square root of -36, take the square of the number as it is, the square root of 36, which is 6. However, because of the negative inside of the radical, we just multiply by I. How can we explain this? Well, let me take a quick side tour here. Okay, so this is the same as saying -1 times 36, right? So that is, in other words, the square root of -1 times the square root of 36. The square root of 36, it's a nice number, 6, but the square root of -1, as we defined it earlier, the square root of -1 is I. So that's why we just take the square root of the negative number and 6i multiplied by I. Okay, so 6i. Just the same way, the square root of negative 25 would be 5i, the square root of negative 49 would be 7i, etc. Now, what about a number like this, negative 11? Well, in this case, the number 11 is not a perfect square. So just write the square root of positive 11 and outside multiply by I. Now, just a quick observation here. Notice I'm writing the letter I in the front. When I had the integer, I wrote the I at the end. The reason why I'm writing it like this in this case is because when we are writing in a rush or something, suppose I read this. For me, this is not very clear whether this I is inside the radical or outside the radical. And in this case, what you mean to write is to have the I outside of the radical. Let's look at another number. Clearly, the number 27 is not a perfect square, right? If it were 25, done, we're done, 5i, but not in this case. However, you might remember, okay, let me do negative 1, 9 times 3. So from intermediate algebra, you broke up a number into factors and you were looking for the highest perfect square. Okay, so I'm going to write this as a product of three radicals the following way. The square root of 9 times the square root of negative 1 times the square root of 3. The square root of 9 is a nice number. The square root of negative 1 is the letter I. And the square root of 3, just square root of 3. Again, notice the position of the I in an effort so you don't confuse it as it is inside of the radical. Alright, so let's move on to the next page. So let's start doing operations with complex numbers. So let's add and subtract complex numbers. Alright, so we are going to be given two complex numbers of this form. All we do is combine the reals with the reals and imaginaries with imaginaries. And the same can be said for the subtraction as well. Alright, let's do a few examples. These are as easy as adding and subtracting numbers. However, be careful when combining like and unlike terms, and be careful with parentheses. For the first example, notice we have parentheses. All we have to do is just get rid of the parentheses. Negative 10 plus 4i plus 2 minus 6i equals, okay, reals with reals, that is negative 10 plus 2, which is going to give us negative 8, and 4 minus 6, which is negative 2i. In the same case, for letter B, for the first set of parentheses, I'm just going to get rid of the parentheses. However, in the second set of parentheses, I cannot just get rid of the parentheses. I need to distribute the negative sign. Alright, so we're going to have negative 8 plus negative, and negative is plus 7i. Again, combine reals with reals, that's 5 minus 8, which is negative 3. And imaginaries with imaginaries, that's going to give us 6i plus 7i, 13i. Okay. Letter C. Letter C might be a little bit tricky. Okay, so notice we don't have parentheses around the negative 4i, and notice there is no real part. So this is very similar to say 0 minus 4i. And then in this case, as we did before, distribute the negative sign. Minus 7 plus 2i. So again, reals with reals, that is, in other words, 0 minus 7, which is negative 7, and negative 4 plus 2, negative 4i plus 2i, that's negative 2i. Alright. Multiplying complex numbers. Look at the format. Basically foiling binomials, because this is a binomial and this is another binomial, so we have the product of two binomials. However, during the process of multiplying complex number, this I squared will show up, which is what we defined in the previous page. So let's go ahead and do this. 1 times 3, 1 times 4i. That is 3 plus 4i, and then negative 5i times 3, negative 5i times 4i. So negative 5 times 3, that's negative 15i. Negative times positive is also negative 4 times 5, that's 20. I times I squared. Alright, actually, let me go ahead and highlight this I squared here, because we're going to use it a couple times to simplify this one. Okay, combining like terms, 4i minus 15i, that's going to give us, okay, this is 3 minus 11i minus 20. What is I squared? Negative 1. Negative times a negative, it's going to be positive, so that's 3 minus 11i plus 20. 20 plus 3, 23. Notice we are expected to write in standard form as defined in the previous page. What is that standard form? The real part first and then the imaginary part. Here we are. Let's do another one. And in this case, for letter B as opposed to letter A, this guy right here, if you look at the form, this is a special form. What do I mean by special form? Notice this is written in the A minus B times A plus B. Does that remind you of anything from factoring from intermediate algebra? This is the factor form of a difference of squares. A squared minus B squared. Right? This is, if you will, although not necessarily, a shortcut. Okay, because the reason why I say not necessarily a shortcut is because this is not going to work for every single example there. Only for examples that have the product of two conjugate binomials. Okay? So, all we can do here is square A, in this case A is 4, and square B, that's 3i. 4 squared equals 16. 3i squared is 9i squared. But again, what did we say about I squared? I squared equals, that's correct, negative 1. Negative times a negative. 16 plus 9, 25. Okay. So that's a couple of examples of multiplying complex numbers. Alright. Finding complex conjugates. We are going to need this when it comes to dividing complex numbers. So the conjugate of a complex number is denoted with a C, with a bar at the top of the letter C, as you can see in the paper. And all we do to find the conjugate is to change the sign of the imaginary part. Okay, let's find the complex conjugates of some given numbers here. Okay, so let's find the complex conjugate of z equals 2 plus 5i. So I'm going to denote z bar equals 2 plus 5i with a bar at the top, and that's going to be 2 minus 5i. Right? All we do is change the sign of the imaginary part. Z bar negative 1 plus 4i. I'm not going to do the bar over here. Okay, I'm just going to go straight to this. Now this one right here, be careful, this is the same as saying 0 minus 7i. So all we do is change the sign of the imaginary part, which is 7i. Turns into positive. And in this case we have z equals negative 9, but that negative 9 is the same as saying negative 9 plus 0i. Alright, so if we find the complex conjugate of this, well, negative 9 minus 0i, it's still negative 9. Okay, it doesn't change at all. Dividing complex numbers. To divide complex numbers, we need to multiply the numerator and the denominator of the given complex number by the conjugate of the denominator. So in this case, let's highlight the denominator. Okay. Highlight the denominator and let's multiply numerator and denominator by the conjugate of that number. So the conjugate will be 4 minus 3i. Okay, so multiply numerator and denominator. I'm going to put parentheses around. Put parentheses around these guys as well. Alright. Now, in the denominator, we are going to take advantage of the property that we looked at in the previous page. If you remember, in fact, we already got the answer to this. 4 minus 3i, 4 plus 3i, and then use the difference of squares form. We do that in an effort to save time. However, if you want to do all the foiling, that is fine. You should get the same result. However, for this guy right here, I'm going to take advantage of it. And I'm just going to use a squared minus b squared. So, a, which is 4, minus 3i, which is 3i squared. And then for the numerator, we will still have to FOIL. If for that case, there will be no way around. Okay, so 2 times 4, which is 8. 2 times negative 3i, that's a negative 6i. And negative 3 times 4, negative 3i times 4, negative 3i times negative 3i. So negative 3i times 4, that's a negative 12i. And negative times negative is positive 9i squared. Okay, so what are we going to get here? So combine these i's, 6i, negative 6i minus 12i, that's going to give us negative 18i. Bring this 8 over here and square the 9i and square the I squared. I mean, simplify the I squared. But again, what did we say about I squared? Isn't that negative 1? Right? This turns into negative 1. And then this is going to be 4 minus 9i as well. 9i squared. But again, what is I squared? Okay, so this will be 8 minus 18 I minus 9 divided by 4 minus 9 times negative 1, which will be turned into a plus. Okay, it will turn into a plus. So let me actually put a box around this guy, okay, so we don't get confused. It's not part of the process, that way we can delimit. And so 8 minus 9 reals with reals again, so that's going to be negative 1 minus 18i divided by 4 plus 9. By the way, I forgot to square this guy, so that should be a 16. 16 plus 9, so that's a 25 in the denominator. However, in this case, we need to write this in standard form. That is negative 1 over 25 minus 18 over 25. 18 over 25 I. Okay, so let's do the next one. Okay, so in this case we need to identify the denominator. Let's highlight and find the conjugate of that number. So the conjugate will be 5 plus 12i. Parentheses, parentheses. Okay, and again I'm going to take advantage of this powerful idea for the denominator of this exercise. Okay, so first of all, I'm going to do the numerator first. I'm going to FOIL 1 times 5, 1 times 12i. So 1 times 5 is 5. 1 times 12i is 12i. On the other hand, 4i times 5, that's 20. 20i. And then 4i times 12i, that's going to be 4 times 12, 48 I squared. Okay, but again, what is this I squared? Recall that's negative 1. We'll take care of that in a second. Let's use the a squared, a minus b rather, a plus b. A squared minus b squared. So 5 squared minus 12i squared. Okay, so first let's combine these two. 12 plus 20, 12i plus 20i, that's 32i. And 48 times I squared, but I squared again it's negative 1. Okay. And then divide that by 5 squared, which is 25, minus 12 squared, which is 144, and I squared, which is, let's denote it as I squared for a second. But again, what is that I squared going to be again? Yes, that is correct. Negative 1. Okay, let me enclose this in a box again. So this will be 5 plus 32i minus 48. Because plus times a minus is going to be minus. And then 25 minus 144 times negative 1. 5 minus 48, that's going to be negative 43 plus 32i divided by, so negative times a negative is going to be a positive. And when we combine 25 plus 144, that's 169 in the denominator. So again, we are required to write this in standard form. So negative 43 over 169 plus 32 over 169 times I. So that is final answer for this example. Let's go ahead and apply this to solving equations in the complex number system. So we want to solve this simple equation, x squared plus 4. So subtract 4 to both sides to get x squared equals negative 4, and then take the square root plus minus. So x equals plus or minus the square root of negative 4 2i. So x1 equals negative 2i, and x2 positive 2i. Alright. Letter B. Let's say letter B. So x squared minus 4x plus 8. So in this case, if we try factoring, this is not going to work because factors of 8 that add up to negative 4, there's no way we can get that. If we had, I don't know, maybe a 6 over here, maybe there will be a way, or other numbers. So in this case, we will have to use the quadratic formula. Which I'm going to write. So a equals 1. There is an invisible 1 in front of the x squared. B equals negative 4. It goes along with the sign. And C equals 8. So negative 4 plus or minus the square root of b squared, which is negative 4, square minus 4 times a, which is 1, times c, which is 8. Divided by 2 times 1. So, smile rule here. 4 plus or minus square root of 16 minus 4 times 8, that's 48. Divided by 2. Alright, so 16 minus 48, that's going to give us square root of negative 32. Alright, do you see the new thing in comparison with the examples we did in the previous sections? So now in this case we have negative radicands, right? Negative radicands. Now, well, the number 32 is not a perfect square. Okay, so we are going to break this up into square root of negative 1 times 16 times 2. And I'm going to highlight the number that has the perfect square. And also I will highlight this one that is going to turn into I. Okay, so divide that by 2. This is going to be 4 plus minus the square root of negative 1. Well, there will be an I involved. The square root of 16 will be 4. And this number just remains inside of the radical. So I'm going to split into 2. 4 over 2 plus minus 4i square root of 2 over 2. 4 divided by 2, that's going to give us 2. 4 divided by 2, 2i square root of 2. Which plus or minus rather, which means x1 equals 2 minus 2i root of 2. x2 equals 2 plus 2i root of 2. And to wrap up this section, we're going to do another example. in which the equation is, by the way, not given in the correct form. So what do we need to do first? Subtract 2x on both sides to get these guys cancelled, and write this in descending order of powers. 5x squared minus 2x plus 1 equals 0. Okay, so in this case, if we do the diamond method, 5 times 1 is going to be 5. Factors of 5 that add up to -2, there's simply no way to get those numbers. So again, we are going to use quadratic formula. But we need to identify a, which is 5. That is the coefficient of the x squared. B, which is -2. And C, which is 1. So let's plug this in. Minus B, which is minus -2. Again, smile rule. Plus minus square root of -2 squared minus 4 times A, which is 5, times C, which is 1. 2 times 5. So let's use a smile rule here. So that's going to be 2 plus or minus the square root of 4 minus 4 times 5, which is 20, divided by 10. Okay, so 4 minus 20, that's going to give us -16. Okay, -16 divided by 10. And the good news here, -16 is a perfect square. What is the square root of 16? Yes, that's correct. 4. But because there's a negative inside, 9. And then 10 in the denominator. So now let's split these two. 2 over 10 plus or minus 4 over 10 I. So 2 over 10 is the same as 1/5 plus or minus 4 over 10, that's 2/5 I. So that means x1 equals 1/5 minus 2/5 of I, and x2 1/5 minus, or plus rather, 2/5 of I. And that's final answer for this equation, and that also completes this section, right? So I'll see you on the next video.